Hi, fifth graders. Today we're going to talk about something called composed figures. And composed figures are just shapes or figures that are made up of more than one rectangular prism. Sometimes we also call these composite figures. So you might remember last year in fourth grade, you talked about combined rectangles. Well, this is the fifth grade version of it, and we're going to be talking about composed figures as they relate to volume. And you might see these shapes in real life. For example, the Olympic podium is a composed figure. It's made up of three separate rectangular prisms for the silver medal stand, the gold medal stand, and the bronze medal stand. An L-shaped swimming pool is a composed figure because it's made up of the two rectangular prisms, the long part of the L and the short part of the L. And my back deck is a composed figure. You might notice that this side right here doesn't come to a point, and it's kind of hard to tell, but this piece of my house sets back a little bit. It's not a perfect rectangular prism. So those are all composed figures, and that's how they might come up in real life. So let's take a look at how we'll see this in math. So again, composed figures are made up of more than one rectangular prism. So the big question then becomes, well, how do we find the volume? So in order to find the volume, we have to do something called decompose the shape. Now that's just a fancy way of saying that we're going to break the figure apart into smaller rectangular prisms and then put it back together to find the volume. So let's try an example. So you see I have a shape over here. I put two green dots on the bottom because now it can match what my shape looks like up here. So I have a row of blue cubes and then below it a row of green cubes. So I used my blocks to make a figure that looked exactly the same. So in order to find the volume, the first thing we have to do is we have to decompose or break apart this shape. So I'm going to split this apart into the top piece and the bottom piece. Now on my paper, that might look something like this. I've got the top piece and the bottom piece. Again, the top piece is the blue cubes, the bottom piece is the green cubes. So then our next step would be to find the volume of each figure separately. So if I'm starting with the top piece, I know that's made up of 1, 2, 3, 4 cubes. So the top figure I can say is 4 units. I can do the same thing with the bottom figure. Since the bottom figure is made up of 2 cubes, I have a bottom figure of 2 units. Now finally, I need to combine all of those mini volumes together to find the total volume. So the total volume would be the top figure plus the bottom figure. I know that the top figure was 4 units, the bottom figure was 2 units, so I can add that together to give me a total volume of 6 cubic units, or 6 units cubed. And if I put this back together to look like it originally did, I can very easily count 1, 2, 3, 4, 5, 6 cubes to show that my answer matches what my blocks had started with. So if you have the blocks, that's great because then you can count and double check your work and make sure that you're right. But what if there are no cubes involved? Well, more often than not, there aren't going to be those cubes. So even if you can't break apart the figure by hand, you can still show how to decompose a figure on paper. So let's take a look at an example like that. I have another shape that has two pieces to it. I've got a green part on the top and a blue part on the bottom. So let's walk through those steps with this particular composed figure. First, I need to decompose it and break it apart. So I'm going to look at the top green part and I'm going to kind of bring over those units with me. And I'm going to look at the bottom blue part and bring over the units for that part of the shape. So now the next step would be to use what I know and find the length, the width, and the height of both of these figures. Well, in the green shape, I'm already told that the length is 4 inches. Now you can't see it on either of the green lines, but the way that I know that it's 4 inches is because I'm going to follow this line all the way down until I find a unit. So it's not listed here, but I know that that line is parallel to this. Still no unit, so I'm going to go down to the point where they meet. Still no unit listed, so I'm going to keep following those parallel lines until I finally get to a space right here that tells me that the length there is going to be 4 inches. The width is given to me nice and straightforward for 2 inches, but the height I don't know. But I am given enough information to figure it out. The way that I would figure it out is I would think that the entire figure, the height of both prisms, is 6 inches tall. I know that the height of the blue prism is 2 inches tall, so I can use those two pieces of information and subtract the 6 inches of the total figure minus the 2 inches of the blue part to give me 4 inches for the height of the green part. So sometimes you might have to do a little bit of puzzling through to figure out the units. Now the blue shape, all of the units already were found out for me. I know the length is 10 inches, I know the width is 4 inches, and I know the height is 2 inches here. So then next, I need to find the volumes of each figure separately. So in the top figure, I know that the formula for volume is length times width times height. I can replace the words length, width, and height with the numbers that match that shape. So the top figure is like saying 4 inches times 2 inches times 4 inches. 4 times 2 is 8, and then 8 times 4 is 32. So the volume of the top figure is 32 inches cubed. I can do the same thing with the bottom blue figure. The bottom figure's volume is length times width times height. I can replace that with the dimensions 10 times 4 times 2. 10 times 4 is 40, and 40 times 2 is 80. So the volume of the bottom figure is 80 inches cubed. Now last, I need to combine all of the partial volumes together to get my total. That means that my total volume is going to be the top figure plus the bottom figure. Since the top figure is 32 inches cubed and the bottom figure is 80 inches cubed, I'm going to add those two values together. 32 plus 80 is 112, so my total volume is 112 inches cubed, or 112 cubic inches. Let's take a look at one more example together. This time I'm going to look at one kind of like the Olympic podium. So first, I need to decompose this figure. Now this one's a little bit different because I don't have just 2 parts to it, I have 3. So I'm going to break this figure into box A, box B, and box C. Next, I'm going to combine my second 2 steps. I'm going to use what I know to find the length, the width, and the height of each figure, and then I'm going to find the volumes of each. So let's start with box A. I know that the volume formula is length times width times height, and luckily in box A, I already know all 3 figures. I know that the length is 3, because that comes from this unit up here. I know that the width is 5. Now again, it's not measured on this line right here, but if I find a line that's parallel, I can go all the way down to the bottom here and find that I'm given my width of 5 feet. And finally, the height is 4 feet. That comes right here. So the volume of box A, 3 times 5 is 15. 15 times 4 is 60. So the volume of box A is 60 feet cubed. Now I'm going to find the volume of box B. Again, the volume formula is length times width times height. And again, I know all 3 of those values. I know that the length is going to be 5 feet from up here. I know that the width is still 5 feet because I followed it all the way down to this dimension right here. And I know that the height is 8 feet because this measurement on the side told me that the entire figure was 8 feet tall. So I know that 5 times 5 is 25, and 25 times 8 is 200. So the volume of box B is 200 feet cubed. Now finally, I need to find the volume of box C. The volume again is length times width times height. But this time I'm a little stuck because I know that the width is 5 feet and I know that the height is 2 feet, but I'm not sure what the length is. That particular piece is missing. So I have to think and break down using the pieces that I know. So if the entire shape is 12 feet, that's what this bottom dimension tells me, I know that box A has a length of 3 feet and box B has a length of 5 feet. So I can subtract those 2 dimensions from the full length, 12 feet, to get my missing length. 12 minus 3 is 9, and 9 minus 5 is 4. So I know that the length of box C is 4 feet. So I can replace that missing question mark with a 4. 4 times 5 is 20, and 20 times 2 is 40, making the volume of box C 40 feet cubed. Now that I have all three of my mini totals, I can do my last step, which is to combine all of those partial volumes together to get my total. So my total volume will be box A plus box B plus box C, which means I'm going to add together the 60 cubic feet, 200 cubic feet, and 40 cubic feet, which means my total volume is 300 feet cubed, or 300 cubic feet. So use this video and the attached notes pages to help you as you do your work this week. Good luck, and I can't wait to see you all soon.